Hello grade 11, Mr. G here, and we're going to be making a video on vectors. This is going to be vectors at equilibrium, so forces in equilibrium, and it's going to be asking further question papers. Okay, so let's go to this question. The question said an object O of weight W supported by two inextensible cables A and B. Cable A is attached to the ceiling and cable B is attached to the wall as shown below. Tension in cable A is 1200 Newton and the tension on cable B is unknown. Ignore the mess of the cable. Here is the picture in which you have two cables. This question is a question from previous question papers, which I really don't remember which one, okay? But it is from there. So this is the object, and the object is not moving, it's at rest. Now, what is the net force acting on the object? Remember, the object is at rest. If the object is at rest, then the net force is equal to 0. That is, in actual fact, Newton's first law. Remember, Newton's first law states that if the net force is equal to 0, then the object will either stay at rest or moving at constant velocity. So let's write here the solution. And the first one, equation 1.1, F net is equal to 0. Remember, and I'm going to just mention this one, if F net is equal to 0, then the object is either at rest or moving with constant velocity. And constant velocity means straight line and same speed. Okay, so this is the important thing. This is Newton's first law in actual fact. Okay, so that is important. Let's go to the next one. The next one said draw a force diagram to show all the forces acting on the object. So I'm going to very roughly and small here draw on the box what forces are acting there. Okay, so on this box there are forces acting. The first one is going to be the tension from cable A. This one here and this one is going to be called TA or FA. It does not really matter which one you prefer. We have T of the object B. Then we go for TB here. This is TB, which is actually unknown. And then the other force that is acting on that is W, is the weight. I'm going to do it from there. And this one is here, W. This is the force diagram showing all the forces acting on the box. However, there is a question for that. We don't have to represent any axis. We don't have to represent anything. But let's do the answers here. Actually, the answer for that question 1.2. So here, question 1.2. What forces are acting there? There is TA. This one does not need to be at scale. This is TA. There is TB, remember I'm not drawing at scale, and that is W. This is W or weight. Those are the forces acting on the object. If that is correct, then you should have 1 mark for each force. Remember, the force must have a heading as well. The heading is the name of the force as well as have head. So each of these arrows must have a head that you can see the head of each of them, otherwise you don't get the marks. Okay, so this is 1.2 and the total mark is 3 marks. Okay, for 1.1, just for saying that F net is equal to 0, you get 1 mark. So remember, everyone should be able to do that one. The object is not moving, therefore the net force is equal to 0. Now calculate the tension in cable B. Before doing that, we're going to do some very little analysis to this question. Okay, so now what we need to know here, first, that I'm going to draw the axis. So the y-axis here on the same box, I don't have to redraw it. However, you can redraw so it is more clear and neat. Okay, this is the y-axis acting, just the y-axis. Perpendicular to that one is going to be the x-axis, and it does not really matter what direction you take. So this one is the x-axis. So I have both axes there. Now let's do one small analysis on the angles. We need to know what angles are those. If we extrapolate this to wide ceiling, we have that this angle of 40 degree is equal to this angle here because they are alternated between parallel. So this angle there, I'm going to do this, is also 40 degrees. Okay? That is no, because they are alternated between parallel. And this angle of 70 degree here on this side, is equal to this angle here, which is also 70 degree because they are alternated between parallel. So I hope you understand what I'm saying here about the angles, because we need them. Okay, so now we have the forces, we have the angles. Remember, force A and force B are actually in none of the axes, so you must determine the component. Let's do a clean drawing here. I'll be back with you after the drawing is done, so we can carry on working on the drawing. All right, here we are. We have here the angles. In each cases, we come in, it's just the free-body diagram from this picture. Okay, here we did analyze the angles. Now we just draw it again in a clean place. Okay, so now what we need to know, those forces have to be taken into the x and the y axis because they are in none on the axis. So let's take first of all TA to the x-axis is coming perpendicular here, and we have the component of TA in the x-axis. Here this one is going to be called TA. Now you can see that EA is adjacent to 40 degree. So if you want to calculate TA in x, which is this one, is equal to TA multiplied by the cosine of 40 degree. Okay? From here you should know that cos of 40 degree is equal to adjacent side divided by hypotenuse. Adjacent side is this one here, and the hypotenuse is the force. So it's going to be equal to applied force in the x-axis divided by the hypotenuse, which is the it's not applied force, with using 10A, tension in A. So if you rearrange this one, the formula is here down. Okay, so this is how to calculate the tension in X. If we go to the other side for TB, now you also have to take TB to the x-axis, and here you will have TB in X. This one here is TB in X. Now the angle here is the one on top, so if you extrapolate here, that say you can see that TB in X is actually opposite to the 70 degree. Okay, so here you know that sine theta, in this case is 70 degree, is equal to opposite side divided by hypotenuse. So sine 70 degrees equal to opposite. Who is opposite? This one here is opposite to 70, and that side is equal to this side. So in actual fact, is the TB in X divided by hypotenuse, which is TB. So from here, TB in X is equal to TB multiplied by sine 70 degree. This is more mathematics than physics. So we have here TB in X, and here we have TA in X. Now, what you need to know, and it's very, very important, because this object is at equilibrium, everything on the left hand side, everything here must be equal to everything there. All right, everything of the left hand side must be equal to everything on the right hand side. So in actual fact, we know now that TB in X must be equal to TA in X. All right, and we then can substitute the formula for each of them. So TB in X is equal to TB sine 70 degree, and this is equal to TA cos 40 degree. Now you have all the information. You are in actual fact looking for TB. So TB is equal to TA cos 40 degree divided by sine 70 degree. If you substitute all the information you have, which is the tension in A is 1200, so it's 1200 cos 40 degree divided by sine 70 degree, and the answer is 978,25 Newton. Please note you can redo the calculations. You can redo all the calculations. This question has, let's see, the number of marks is 4 marks. So we're going to has 1 mark for any of those two. To equate them equal, you need to know that everything on the left hand side is equal to everything on the right hand side. 1 mark for the substitution here, 1 mark for the substitution there, and 1 mark for the answer, for the final answer, and that is 4 marks. Okay, so I hope this part is clear. Remember, everything is coming with the angles. I recommend you all to come to the picture and do the analysis of the angles there, and you can work and play with those angles. Okay, so 1.4, calculate the magnitude of the weight, okay, of the object. So 1.4, you are looking for the weight of the object. Okay, so let's do it here. Let's do it here. It's question 1.4, and let's redraw the picture. All right, here we are. So now we have to take this tension in A and take it also to the y-axis as we did with the x, and here we are going to have the component of the cable A in the y-axis. Now note this side here is like this one here, they equal. So this one is also TA in y. In actual fact, you can see it's opposite to the 40 degree. So if you write the formula here, you have that sine 40 degree is equal to opposite side divided by hypotenuse. The hypotenuse is the force, is TA, and opposite side is the tension in the y-axis. So if you rearrange this one, you have that sine of 40 degree is equal to opposite side, which is tension in A in the y-axis, divided by hypotenuse, which is tension in the A. Alright, and if you rearrange for tension, you have the tension in the A, in the y-axis, tension A in the y-axis is equal to tension A multiplied by sine of 40 degrees. Okay, sine 40 degree. So this is how to calculate the tension in A. On the other side, on the left hand side, we have the same situation. We have to take this one to the y-axis. We actually have it here. I don't know if you can see properly there. That one is TB in the y-axis, which in actual fact is this one here. Right, but you can see that in this case is adjacent. So from here you can see that adjacent side, which is the TB in y. So cos of 70 degree is equal to adjacent side divided by hypotenuse, and adjacent side is equal to the TB in y divided by TB. So if you arrange this one, you have that tension B y is equal to tension B multiplied by the cosine of 70 degree. So now we know the components of each vector in the y-axis. We have now what we need to know: the object is in equilibrium or is at equilibrium. So everything on top must be equal to everything at the bottom or under. What do we have on top? What do we have on top? We have the force. Let's use tension. We're using tension up until now. We have TA in y, and we have TB in y. What do we have at the bottom? W. All right, at the bottom we have W, and that is in actual fact what they're asking you to calculate. So if we substitute the formulas here, we have that W is equal to TA is TA sine 40 degree plus TB in y is equal to TB cos 70 degree. So W is going to be equal to, when you substitute, TA is 1200 sine 40 degree plus TB was calculated, and the answer was 978.25. and 78,25 cosine 70 degree. The answer for weight is equal to 1105,93. Remember to redo all the calculations. They only want the magnitude. You can redo all the calculations just in case I make a mistake in any of them. Okay, so here is the one, and then if you do it in that way, this is also 4 marks for this question. Let's make sure there is also 4 marks in that question, and then the mark allocation will be 1 for saying either of those. Either of those you will get 1 mark. 1 mark for the vertical component of the cable A, 1 for the vertical component of the component in the y-axis for cable B, and 1 for the final answer, that is 4. And when you calculate the total mark of the question is 12 marks. Okay, so this is all about vectors. You need to remember that if the object is at rest, everything that you have on the left hand side must be equal to everything on the right hand side. For example, here, everything here must be equal to everything there, right? Everything, because sometimes you may have more than one, and everything that is on top, everything that you have on top must be equal to everything at the bottom. You can see on top you have 2 forces, so that is the main thing in this equation. It's not a difficult, it's not big thing, it's more intimidating. The picture is intimidating anybody, but the question is not difficult. Thank you very much for watching, and good luck.